So, good afternoon, everyone, and welcome. Thank you for joining us for designing low power IoT from antenna to cloud. Today, we'll explore the design elements of a low power IoT device through the lens of collaboration across the stack, from hardware platform to connectivity to antenna integration to the end application. My name is Karen Soriano, and I'm the product marketing manager at Ignion. I'm very happy to introduce our expert panel, a great group of experts. So, first off, we have Patrick Noordhoek, Regional Sales Director at Nordic Semiconductor. Patrick works closely with customers and partners, bringing low power wireless products to market across Bluetooth, cellular, IoT, and other wireless technologies. Next, we have Loubna Madi, Engineering Manager at Ignion. Loubna leads the team supporting customers in the development of connected devices and has spent the past 5 years helping IoT companies integrate virtual antenna technology from early design through optimization. Now, joining us from Onomondo is Giulia Manzini, Strategic Partnerships Manager, working at the intersection of connectivity and ecosystem collaboration. And finally, we have Roel Loeffen, co-founder at Ampel Technologies, focused on developing connectivity solutions for IoT applications and helping bring connected products to market across industries. So please join me in welcoming Patrick, Loubna, Giulia, and Roel. Now, what makes this discussion especially relevant is that this is not just a theoretical panel. Ignion has been working together with Nordic, Onomondo, and Ampel around the Ampel device and case study story. So when the opportunity came up to contribute to Onomondo's panel discussion, this topic felt like a very natural fit. And if you think about it, when you talk about designing up for low power IoT, you're really talking about the full chain, the reference platform, the connectivity layer, the antenna architecture, and the final device design. And that is exactly what this group represents. So today, rather than looking at those pieces in isolation, we want to discuss what happens when they come together as an integrated solution for real customer problems. So now let's start with a quick overview from each of our panelists. So Patrick, maybe I can start with you. Maybe you can tell us more about the Thingy 91X. What it is, what problem it solves, and why platforms like this matter for teams designing low power IoT products.
Yeah, thanks. Thanks for giving us the chance to present something on the Nordic Thingy 91X. So basically, the 91X is developed first of all to show the Nordic silicon, the 9151 device, which is prominent on the thingy you can see, it's like this one here. So basically, what is there is to combine Nordic chip, the Ignion antenna solutions. You can see different ones on there for the different kind of interfaces. It showcases the Onomondo connectivity solution. So basically, it's out of the box. We ship it with the Onomondo SIM card, and out of the box, it means this device is working straight away. So a customer who receives this can get started on cellular IoT right away. And the last bit that's included on it is the Nordic Cloud Solutions. Allows you to connect immediately to cloud solutions that we offer, basically. But that's the Nordic Thingy. The idea behind it is to support customers like Ampel Technology to design reliably, with certainty, rather usual complex cellular solution, which cellular solutions are typically. So basically, it's part of making our cellular IoT made easy, as we state, and I think it really is. Antenna design is a huge challenge. It makes it easier because there is a reference design to start with, and Ignion helps further. Picking the right connectivity supplier is hard. Coming up with a good standard, a good quality solution there is good for a customer. So basically, we show Onomondo as a reference there, and that helps a lot of customers to get going.
Thank you, Patrick. You already mentioned about Ignion. Let's now go to Loubna. Loubna, can you tell us more about Ignion's antenna solution inside the Thingy 91X?
Yeah, thank you, Karen, for the introduction. So from an antenna perspective, one of the main challenges is integrating multiple radios into a small form factor PCB like the Thingy 91X. So the key point here is that Ignion antennas are non-resonant technology. So for those that are not familiar with the non-resonant concept, what does it mean is we don't have dedicated antennas for covering dedicated protocols. So the same antenna can cover different protocols. So the way how we work is thinking about the whole system. No, we have the antenna, the matching network, and the ground plane, and everything together radiates to the outside. And by tuning the matching network, we decide which frequency to cover. So for instance, we can use the same antenna to cover different protocols like GNSS, LTE, Bluetooth. The only thing that might be different between the designs will be the bill of material of the matching network. So knowing that, having this ability to control the antenna's behavior by just tuning the matching network help us and helps, of course, our partners to shorten the design cycle. That is a super important point here. So circling back to the Nordic, to the Thingy 91X, we managed to cover cellular, GNSS, and 2.4, meaning Bluetooth and Wi-Fi. And the thing is that due to the PCB dimensions, we had to implement an active solution for LTE to meet the targets in terms of antenna efficiency. As you know, it's difficult not to cover the low bands, the sub-giga bands with a small form factor PCB. But with the active solution, we could meet the targets, making the entire device improved and making it more lower power consumption. So yeah, that will be like the highlight in terms of antenna integration.
Thank you very much, Loubna. Now let's go to Giulia from our host Onomondo. Maybe you can explain more about Onomondo's soft SIM and how it fits into the story, particularly for teams that want to simplify deployment and scaling.
Absolutely. Thank you, Karen, and the rest of the team for putting this together, and very happy to be here. So Onomondo Soft SIM is, I want to say, the most integrated virtual SIM card out there, already thanks to strong partners in the Silicon environment like Nordic. This has become, I want to say, a standard for low power applications. The fact that soft SIM can live in the trust zone of Nordic modules allow design houses as well as end clients to have the most embedded out-of-the-box solution. It really takes just a few steps to make the SIM card profiles be fetchable from our platform, as well as be up and running with a connectivity solution on all different technologies and RATs. The idea really came from also lowering, I want to say, the microamperes that are needed to keep the device or the module running in idle mode. So something very, very suitable also for optimizing more than the usual any low power application. Nevertheless, it's also the most cost-effective SIM card out there, making it a €0 profile. And at the end of the day, we see the most wide adoption also because of our overall offering that is created on top of it. The idea is that soft SIM is, of course, a SIM card format, widely adopted and suggested for low power application. Nevertheless, what really makes us stand out in cases like this one, where prototyping and testing is essential, is really the visibility that Onomondo can offer in terms of data packets and network insights, which allow rapid prototyping and, let's say, turns back or eliminating all roadblocks that can emerge from the technical side of bringing a device out there, basically. Really looking forward to hearing more of this from the Ampel experience, both for the soft SIM application and the wider use of their platform.
Thank you very much, Giulia. Now, Roel, bringing it to the final product context. Can you tell us about the Ampel medical monitoring device? What kind of device it is, what the design priorities were, and what were the other applications or use cases that you had in mind for it?
Okay, thanks, Karen. Yeah, at Ampel Technologies, we are integrating IoT solutions, and we had in mind to have a device which is really usable in multiple markets. And first, we addressed the medical monitoring device, but we've built the device in such a way that we can adopt to different kind of monitoring solutions. But we were restricted to quite a lot of parameters, so to say. So the device should be small and it should run up to 5 years on a single battery charge, which is really a challenge because this medical device is not easily reachable by the end customer. So it should be autonomous for a long time. And we came in touch with this ecosystem, basically introduced by Patrick via Nordic, and it gave us the opportunity to reach all the parameters we would like to reach. So it should be cost effective. It should be on the market within a short time. So the lead time was very important. We have our specialists on hardware design and software design who can handle this. But as Patrick pointed out, it's very complex to build a LTE connected device from scratch. So this ecosystem gave us a boost. The device is pretty much looking like the Thingy 91X, but it's tailored on many places. So looking at the antennas, we've used Ignion solutions for all three connectivities, GNSS, LTE, and Wi-Fi. And this gave us the opportunity to do to reuse a lot of the existing platform aspects. Also, we got great support from Ignion to get our designs ready, and even validation at their side was possible for the antennas. On the other side, still we had to put a lot of software effort into to get our application running on the Nordic, but getting the LTE, LTM and narrowband IoT running was really flawless in combination with Onomondo SIM card. We started off with a physical SIM card only for testing on the 91X, but in our device we completely removed the SIM card slot. We removed the eSIM, so we 100% rely on soft SIM of Onomondo, which is really been a pleasure. It reduces cost, but it's also very flexible. We're shipping out these devices now in a couple of hundreds, and our production facility is also able to connect to the Onomondo backend in order to fetch the SIM cards and get it all running. So yeah, the whole ecosystem gave us the opportunity to build a platform which is for us very easy to tailor for other markets. This 5-year battery life is really something it looks like we're going to reach it. We have to prove it. It's also very relative where we place the device and how good the connectivity is over there. Also for us, it's very important that Onomondo is a roaming device. In Belgium, Netherlands, France, we are testing right now. This gives us a little bit of confidence that it will behave in the same way over the different countries. So we're very pleased, and we are about to address different markets with this product as well. We have some opportunities, industrial asset tracking, but for now we focus on the medical monitoring device.
Thank you so much, Roel. Now, coming from the responses here, let's build on this discussion a bit. One of the interesting things here is that this project spans several layers that are sometimes or often treated separately. You have the platform, you have the antenna, connectivity, and the application. I'd like to ask the panel, what do you see as the biggest advantages of an integrated approach, such as the Thingy 901X, or in general, when solving end customer challenges, such as designing a low power IoT device? And equally important, what do you think are the trade-offs or disadvantages? For example, are there any risks, any design constraints, any dependencies that you foresee in this kind of approach? Perhaps I'll circle back to Patrick.
Yeah, you need to have a platform approach and these kind of connectivity solutions. Just putting a chip on the market is not enough. Customers need to be helped to get to market quickly and efficiently, and build trust in the cellular connectivity solutions. So basically, the platform solution is for Nordic the only way to go and the only way to put products in the market.
Thank you. And perhaps next go to Loubna next.
Yeah, well, in general, the issue we typically identify with integrated fixed solution are the limited flexibility to make design modifications once the solution is closed. So that will be a constraint for us, but linking to the positive aspect is that in this case we can tune the antennas if the requirements change. We are talking about this flexibility, but of course we are still not on dependence with the radio and the other elements of the solution that also must not support these changes. For instance, imagine the LTE antenna covering certain bands, and 6 months later, those requirements change to another different bands. So in this case, from the antenna perspective, we could just shift the antenna response by modifying the matching network. That will be super easy, but we need to make sure that the radio supports this change, the software, and so on. So at the end, we have this trade-off between our solution and the ecosystem, of course.
Thank you, Loubna. And let's go to Giulia. In terms of the soft SIM, or in general, what do you see?
Definitely. So I think SoftSIM really comes across as a solution that would have only been possible thanks to a strong partner ecosystem. Nordic definitely being an example, as well as the design houses and distributors in general that work with us, as well as the end clients adoption. So the solution really came to life because of the need for the industry to improve low power devices. And now I do also see a lot of questions being asked around the different data packages being sent back and forth and the kind of improvement to reach specific battery life. This is really the reasoning that we applied to bring this this SIM card format to life, and really the integration made possible with such strong partners such as Nordic per se, really makes, let's say, the best of both the silicon world and the connectivity in a place where all components can be improved beyond what is usually considered the classic device, I want to say. Constraints is, of course, this is not always relevant for all types of applications. We really recognize that as well. That's why we work with, I want to say, specific partners that have an interest in improving this kind of aspects, as well as try to optimize, I want to say, soft SIM application at all times, also with, I want to say, the recent news Nordic brought to the market, new kind of modules, new kind of technologies being, let's say, becoming a standard. Other parts, we are not shying away from where the market is heading, also with SGP32 as for previous sessions. So soft SIM is really, I want to say, the most optimized virtual SIM card for low power devices. Not all devices needs to be low power. Maybe this is my my main take, but very happy to be working with partners and clients that really recognize these points as being crucial for their deployments.
Thank you, Giulia. And now let's go to Roel, because I think these solutions were really designed for design houses such as them.
Yeah, thanks. Yeah, for us, it was really important to choose an ecosystem rather than only a chip for the device. Often we choose just a chip which fits our requirements with regards to technology, with regards to interfacing. But in this case, when you go into cellular, the complexity rises quite fast, especially with the software stack up and handling all the modem commands and that kind of stuff. So also connecting to a backend, the NRF cloud from Nordic was really an advantage. So having this ecosystem, yeah, was in our case a must, because we had a small short time to market, and we had a lot of requirements to already take care of by our engineers, and this ecosystem gave us the trust we can do it without becoming specialists on extreme specialists on all the fields, like designing antennas, like being completely aware of what's going on in the SIM card world, debugging modem commands, that kind of stuff. We are a product builder and we are a product shipper. So that's the ecosystem was a must for us, and we're really pleased we end up with this one. You don't know upfront, but it worked out really well. I also see some technical questions in the Q&A. I don't know if we're gonna address those later.
Yes.
But
We're gonna jump to them right after this one. Actually, we're
Okay.
gonna start with the Q&A. We're gonna get the ball rolling. All right. So yeah, let's start the Q&A. There is a question here I think would be great for Patrick. It's a question for the Thingy 91X if it is PTCRB approved. So Patrick, can you go ahead?
Yeah, sure. Thanks. Thanks for the question. I just have to say all our modems, and in this case, the 9151 has a modem code inside, the modem core and modem code software, have been approved by all the North American operators. The Thingy itself is FCC approved as well.
All right. I guess if you can stay on, Patrick, because I think there's a follow-up, another question which maybe you can answer. Have you tried to improve battery life with data compression and sleep mode? And also we have David who also asked, yeah, sorry.
I see the question. So
Yeah,
basically,
go ahead.
5 years, is there an improvement on battery life with data compression and sleep modes? Interestingly, there is usually the amount of data that is sent is not determining the amount of energy used. Most of the energy used is setting up a connection, keeping a connection, headers, etc. And then you quickly find out that data is not really making the difference here. Sleep modes, on the other hand, is a completely different story. Yes, sleep modes have been extremely optimized in all Nordic cellular solutions. So we go really far to get the absolute best performance on sleep modes. And there are the network operated sleep modes, the network supported sleep modes, and beyond that, we have more sleep mode functionality built into our system as well.
All right. I guess from the same from David as well. He's interested to know if or to understand your payload and intervals as well as number of sensors.
Yeah, okay, I can answer that. So for this device, we have to wake up once a day, and we stay awake for 1 minute. Indeed, like Patrick said, we use the deep sleep modes which Nordic provides us. We have, with regards to sensors, we have audio sensors. So we have basically a microphone. We do also some signal processing to the things we receive with the capabilities of the 9151. So yeah, we wake up once a day. We send the data we collect within this minute. We send to the NRF cloud. And that's basically it. So that's most of our energy is consumed during sleep mode.
Perhaps just a follow-up rule. What type of sensors were used again?
Yeah, it's a microphone. So that's a sensor. We also have the ability to track movement. So the device also wakes when it's moved. Gyroscope functionality. We report also the temperature and humidity, which we sense. But the primary application is around audio and listening to the asset we're tracking. The asset we're tracking will beep when it's malfunctioning, so we need to signal this.
All right. And then I think there's I think that was mentioned earlier about the PTCRB, and you also mentioned, Patrick, about the FCC certification. Can you, if I think you can see the question there, can you perhaps expound on that one?
Yeah, as far as I remember, it is FCC certified, but as a device, as a thingy, generally how we see it as a customer uses the Thingy 91 as a reference device to get started and build their own, just like Ampel Technologies has been doing. So bear me the details here because I don't have that exact. I'm not based in the USA. My sales colleagues there are probably able to help you better with this. So yeah, one way I understand what you're asking, I don't have the exact answer here. The other question I see here is that in rural areas, Cat-M signal is struggling. Does Nordic have plans to support Cat1? I assume Cat1 bis you mean here on this platform. Issue being here, Cat1 bis is a full duplex platform. The chip is not made for a full duplex solution. It adds a massive amount of complexity to both chip design and external filters. So it's not.
All right, thank you. And I think you've already covered most of the questions.
I think so.
Yes. I guess, well, we're almost out of time also, so maybe we can already wrap up. I want to thank, yeah, that was a very quick session, I just realized. So let me just hold on, go back. Okay. So I just wanted to share with everyone that at we are the Ignion, very much believe in this ecosystem approach in terms of answering the real customer problems. We believe that RF innovation, it's not just a solo act, it's a group effort. And this is why partnerships across silicon leaders, connectivity, antenna design, and device development matter so much to us. And when those pieces work together, we believe that engineers can spend less time fighting complexity and put more time into building products that move markets. And you can even see that spirit in this group selfie in this slide, because over the past 3 weeks, we've had the wonderful opportunity, the chance to meet in person in several events. And it's been a great opportunity to strengthen this kind of collaboration that turns separate technologies into real world solutions. Now, for those who are not familiar with who we are, so Ignion, and from Ignion's perspective, our message is simple. We have one antenna component, one antenna solution, and we can cover any radio, any band. It's all about, for us, turning RF integration into a more predictable process. We enable future-proof multi-band and multi-radio designs, one design path that can design globally. We're hoping to support you with faster integration and certification, and through our antenna integration platform, Amsign.ai, as well as our expert engineering services team. And one of our strengths is actually really smaller devices, such as the Thingy 91X. We support it with a strong antenna efficiency, even on really constrained PCBs. Our value is not really just on RF performance, it's also on speed, predictability, and a shorter path to market. And finally, just to close, if today's conversation sparked ideas for your own products, there are several resources to keep exploring. We have our Virtual Antenna Academy. This is an online course if you want to learn more about our technology. We also have Oxion.ai. This is our end-to-end antenna integration platform. It's really cool and really fun. We also recently launched these project upgrade plans, and this will give you access to all of the Ignion products, engineering support, and lab services, so you can finally build your prototype. Really exciting. And finally, for our design guides, technical documentation, including the design guide, which can probably answer if we missed any of the questions from the audience, please download this. Just go to our ignion.io/resources-support. And with that, I would like to thank again Patrick, Giulia, Loubna, and Roel for joining us. Perhaps we can have some closing messages or final messages from our panel. So maybe let's start with Patrick, perhaps. Any final words?
Yeah, thanks for giving the opportunity to actually show off the great cooperation we have with the different partners, and resulting in a great product from the customer, Ampel Technologies. I really appreciate working together this way. Thanks.
And perhaps next up, let's have it from Loubna.
Yeah, I would like to thank this space to talk a little bit how different partners create an ecosystem. And thank you, Karen, for the highlights regarding the Ignion technology, and for helping to make this happen.
Thank you very much. And yes, Giulia, one of our favorites.
Absolutely. Yeah, great to be working on this all together. And thank you, Ignion, for taking the lead and bringing this to life, both in real life. I want to say meeting in person, and creating a great story of how our partner ecosystem can come together. It's been really great working with you all.
Thank you. And of course, Roel from Ampel Technologies.
Yeah, thank you all for hosting, and thank you for having us to show our end product. We're really happy to use the ecosystem. So feel free to reach out to Ampel Technologies if you want to use the ecosystem. We've built up a lot of knowledge around it. So find us at ampel.tech, and hope to see you soon. All again.
So thank you all for being here. We hope this discussion gave you a practical view of what low power IoT design really looks like when the ecosystem works together, from antenna to cloud. Thank you very much.